Hello and welcome to our mathematics lesson. We continue to cover the topic on properties of geometrical figures. This particular lesson, we are going to look at congruent triangles and another subtopic on the proof by using concurrency. At this juncture, let's be able to let's define what concurrency means in terms of triangles. We normally refer to two or more shapes as being congruent whenever the sides or the angles are equal. That is, when two shapes have the same shape and size they are said to be congruent, i.e. they are equal. And for them to be equal in shape and also in terms of the size, then that means that all the sides that are encompassing that particular shape or figure must be equal to the other one. And at the same time, the angles inside those two particular shapes, they should correspond and they should also be equal. Now we normally match the lengths of that particular those particular two figures, or we match the angles of those particular figures. And whenever we match the sides, the rule that we shall be applying is the side rule, where you consider the side of each of the triangles. Then sometimes we might use the angle for us to say that these particular triangles are actually equal or they are congruent. So that is when all the angles are equal. But sometimes we can use the side angle side. We can also use the angle side angle for us to be able to detect or say that these particular shapes are congruent or they are the same in terms of their figure. We are going to look at a number of aspects to be conserved or to be observed whenever we are dealing with congruency in triangles. Now, the first thing you've been able to say that congruent figures have the same shape, and of course the size. So whenever two shapes have equal size and they are of the same shape, they are referred to as being congruent figure. That is, they are identical in any way. So whichever way you choose, like you choose to use in terms of the size or in terms of the angles of those particular two figures, then whichever way you choose to refer to them as being congruent, then they are going to be identical. And again, if two figures are congruent, one of them can be transformed into another by using. So there are a number of transformations in which you can be able to use to transform one figure into the other, so long as they are congruent. By using one, we have rotation, And in rotating, you can either rotate them clockwise, anti-clockwise on a given angle, or using a particular point of rotation. Also, reflection, where you have the mirror line and reflect it on the other side. And then the last way in which you can be able to transform similar or concurrent figures is by use of translations. That is translation for them to match the other figure. So you can be able to match one to another by use of rotation. That is, and when you're using rotation, you must have at the center of rotation and the angle of rotation. And it can be a clockwise or anti-clockwise. Those ones that are measured clockwise are usually negative angles. Then for the anti-clockwise, all those are positive angles. Then we have reflection, which you have said we must have the mirror line, then the object is reflected on the other side. Then finally on translations, where you can be able to use either the vector translation or the matrix transformations for you to transform one figure into the other. So that means you must have the translation matrix or the translation vector. Then if we have two quadrilaterals, let me have this one just very quickly, where this is A, B, C, D, then we have P, Q, R, S, and we are told that this one matches to that. No, it matches to this one. We are also told that this one matches to this one, and we are told that this one matches, sorry, this one matches with this one. Then finally this one matches to that. Then we have that particular angle and this one that when translated will go there and X on the other side. So if we have them like that, so this will be our 0, then the remaining we use a square. Now in this particular two shapes, as you can be able to see, AB corresponds to SR, and that BC corresponds to RS, and that DC corresponds to PQ, and that AD corresponds to QR by those special marking. Then on the angles, angle C corresponds to angle P, angles B corresponds to angle S, angle A corresponds to angle R, and angle D corresponds to angle Q. So in this particular figure, we can be able to call those particular sides as matching sides. So as you have been able to mention, AB matches SR. So SR and AB are referred to as matching sides or corresponding sides. Then for the angles, we refer to them as corresponding angles or matching angles. Now, another point of concern is that corresponding sides are opposite. The corresponding sides are opposite. They're actually opposite equal corresponding angles. That is what we're able to discover in the last, before I wrapped, that for those to have corresponding sides, they are usually found opposite, equal, or corresponding angles. Now we have tests for concurrency in triangles, but before we go to the test on concurrency, let's try to observe these two figures and try to come up with the matching sides or the matching angles. So we have a triangle, A, B, C. Then I have another triangle, X, Y, Z. So we can be able to match, so let's put there the matching, that this one and that one, this one and this one, then this one and that one. Angle A should correspond to this angle X, and angle C should correspond to angle Y, and that will leave us, or make this one correspond to that. Then that means that the last one, X, will correspond to that particular X. Now if we are given these two figures and we are asked to match the corresponding sides and match the corresponding angles, for the corresponding sides, you can be able to see using the marks. AC, for instance, has a single mark, so we locate a single mark on the other side, it is YZ. So this tells us that AC corresponds to YZ on the other side, YZ. What about CB? CB has two marks, so on the other side, the one with two marks is XY, so corresponds to XY. Then finally, AB. AB has three marks, and it corresponds to this side, which has got also three marks, hence it corresponds to a point called XZ. What about on angles? You can be able to see this one is X, this one is X. So this tells us that angle A corresponds to angle Z. Angles B, where is a dot, corresponds to angle X. And finally, angle C will correspond to angle Y. So this is something I wanted to mention before we look at the test for triangles or for concurrency in triangles. Now we have got the side-side test, as I had mentioned during my introduction, which takes into the account all the sides of the pre-existing figures. So if all the sides are going to be similar, then that will tell you that those two particular triangles are going to be similar. And which basis have we used? This side and the other side are equal. This side, the other side are equal. This side and the other side are equal. So all the sides are equal. So in that case, we use the side test. So the first test is side, which you call the SSS test. Now with the SSS test, if and only if the three sides, if the three sides of a triangle are respectively equal, are respectively equal to the three sides of the other triangle, then the two triangles are concurrent. In short, if we had a triangle ABC and we have another triangle XYZ, where this side is equal to this side is equals to that side, and this side is equals to this side, then on the basis of the side, then these two triangles will be said to be similar. And that is the first test for concurrency in triangles, the side test. The second test is the side angle side. Side angle side, in short, SAS. That is the SAS. So that means two sides of the two triangles are going to be equal, then one of the angle is going to be equal, and this angle should be that included angle by the two sides. So we are saying that if two sides and an included angle remember that in this case it must be unincluded. That is, if this is one side, this is another side, the angle in question is the one that has been included. And an included angle of a triangle are respectively equal to the two sides and an included angle of the other triangle, then the two triangles are said to be concurrent. So whenever we have that scenario where the two sides and included angle of both the two triangles are similar or equal, then by side angle side, those two triangles will be similar or they'll be concurrent. In this particular case, we can have these two triangles where we are told that this angle and this angle are similar, then this side is equals to that side and this side is equals to that side. So we are now leaving the other one. So without even question, given that this angle is equal, this side and this side is equal, then that will tell you that of course or automatically this will also be equal. So this, by the virtue that a side, included angle and side of the first triangle is similar to the side, included angle and side of the other triangle, then these two triangles will be congruent. We have the third test for congruency, With the third test for concurrency, this is now the angle side. And if we can be able to shorten this will be AS, where we now consider the two angles and one of the side test. So we say that if two angles at one side of a triangle are respectively equal to two angles and one side of another triangle, then the two triangles are said to be congruent. So this is now on the virtue of the angle side, and we can have it as in this case we have this triangle where we are told that this angle is equivalent to that angle, this angle is equivalent to this angle, then we have this side which is equivalent to the other side. So with this again, if you look, two angles and a side are equal, then that will automatically tell you that this angle and this angle are going to be equal, and therefore this side and this side are going to be equal. And under this angle side, we can be able to term these two triangles as being similar. Then we have the last test, which is the right angle and hypotenuse and the side test. That is test number 4, which we are saying is the right angle we have hypotenuse, we have a side test. It's called the Rhs test. So with this, if the hypotenuse and second side of a right angled triangle are respectively equal to the hypotenuse and second side of another right angle triangle, then the two triangles are said or termed to be congruent. So in this case, if we have such a right angle at this particular point. We have another one at this particular point. Then this side are equal, and also the hypotenuse are equal. Then in that case, these two triangles will be termed, or will be said to be congruent by the right angle, hypotenuse, and one of the side. Because of course, if this and these are equal, these are equal, that will tell you automatically that the third one they are going to be equal. And then of course we have got the right angle there. So to sum up the 4 tests, we had the first test, which we said is the side test. The second test, we talked of the side angle side. The third test, we have talked of the angle side. And then the last one, we have talked about the right angle, the hypotenuse, and the side. So these 4 tests are very critical in determining whether those particular triangles are similar or not. For the SSS, we have said we consider on each of the sides, are the 3 sides of one triangle equal to the respective sides of the other triangle. If they are equal, then they become congruent. Side angle side, and here we are saying that the angle should be an included angle, so that if you are mentioning of this side and this side, the included angle is that angle that is formed between the 2 sides. So if of one triangle are equal to the other triangle, then they are going to be congruent. Then we have got the angle side, where 2 angles and a side are equal. For both triangles, they will be referred to as congruent. And then finally, on the issue of the right angle triangles, if it has a right angle, then the hypotenuse of the 2 triangles are equal, and one of the shorter sides are equal, then those 2 triangles will be referred or will be termed as congruent. Let us look at questions on congruency of triangles. Number 1, which congruency test will be used to show that these pairs of triangles are congruent. Number 1, we have such a triangle and another triangle. This angle and this angle are equal. This side and this side are equal. This side and this side are equal. Number B, we have such, where this is 90 degrees, that is 90 degrees. This side and this side are equal. Then this side and this side are equal. So let us look at these 2 first. So in the first case, we have one angle and 2 sides, one angle and the 2 sides. So which test are we going to use? So it is clear we have an included angles and 2 sides. So this will tell you that for number 1, we are going to use the side angle side test, that is SAS. So we're going to use the SAS because 1 or 2 sides and included angles are similar or equal. Then for part B, we have two right angle triangles. We have got the first and the second one. Then the hypotenuse or the longest sides are equal for both. Then one of the sides are equal. So which rule or which test of concurrency are we going to apply? Given that these two are right angles, hypotenuse are equal and one side is equal. That tells us that we're going to use the right angle. We use hypotenuse and then one side test. This in short will be the right Rhs test for us to be able to show that those two triangles are congruent. Number C. Number C. We have this triangle. We have another triangle. And in this triangle, we are told that this is x. Also, this is x. And that this angle and this angle are equal. And that this side and this side are equal. So you can digest that one meanwhile, where we have got two angles and a side. Then number D. We have such a triangle. This side is equals to that, this side is equals to that, this side is equals to this side. So for this first case, we have got two angles and one side. So that automatically takes us to the angle side, because you have the angle and one side. So this is the angle side test, or the AAS. For this one, all the three sides are equal. So this simply goes to the side test, or the SSS, because all the three sides of the two triangles are similar. Another example, example 2. We are told find the value of the pronumerals. Part A, we have a triangle. There are two triangles. So for the two triangles, we are told that this angle and this angle are similar or equal. Then this angle and this angle are similar. Then we have y, we have 5, and we have 3. Here we have 7. There we have got 3, and this one we have got x. Number B, we have a triangle and another. The first one, this is angle B and is equivalent to this angle B. This is 25 degrees. This is 100 degrees. This is a degrees. We are also told that this side is equivalent to this side, and that this side is equivalent to this side, and that this side is equivalent to that side. So we want to solve the values of the pronumerals in these two questions. Now for the first question, we have been told that this angle is equivalent to that angle, this angle is equivalent to this particular angle. So the line in question that is containing the two angles is this particular line. So this line and this line. And that will automatically tell us that this line is going to be equal to this line. And therefore, if this is 7, this is also going to be 7. So that tells you that y is equals to 7 units. So this is 7. Now, we are told that we have this angle and this angle, then the other one is left hanging. Then we are told that this is 3 and this is 3. So that tells us that this side and this side are going to be equal. So that will leave us with this side and this side to be equal. And because this is x and this is 5 and they are congruent triangles, then that means that our x is going to be 5 units. For part B, we have all angles and all sides being equal. Now we are told that this is 100 degrees, this is A degrees, this is B degrees. Then one of them is 25. And as you can be able to see this side and this side, we have an included angle like that. So that means where we have got the 3, this side and this side, an included angle, those angles, included angles are going to be equal. So if this is A, this will definitely be 25 degrees. So A is equals to 25 degrees. Then if this is 25 degrees, we can be able to find the value of B, because we understand that angles in a triangle add up to 180 degrees. Therefore, B will be equal to 180. We subtract the sum of this, which is 125, and that will give us 55 degrees. So B is 55 degrees. Now if you look at B, on this side, it has 1 and 3. 1 and 3. So that will also tell us that this particular angle is going to be 55 degrees. So the value of A is 25 degrees, the value of B is 55 degrees. So we now want to move and look at another subtopic on how we can now be able to use the concurrency test in proving of concurrency. That is using concurrency So sometimes we are forced or we are given situations where we are supposed to use concurrency test as proof in different scenarios or in different mathematical problems. Now, we can be able to say that a proof is a mathematical sequence. In mathematics, that is a sequence of correct statements that leads to correct answers. So for you to finally go to the correct answers, you need some basic factual statements, which they should be sequential in nature. Like for example, if we use the case of boys, we understand that boys are quite different from girls. So if we can be able to say, maybe at the age of around adolescence, we can be able to say that boys have beards while girls don't have beards. So if we give a statement and say that boys have beards, that is scientifically correct. It's a correct statement. Then we say that John has beards. Again, we have observed this particular person and we have found out that he has the beards. So what is the conclusion, or what is the answer? What is the answer? We can now be able to conclude that John is a boy. So this is an answer that has been built up from the two factual statements. Boys have beards, John has beard, therefore John is a boy. So the same can happen in mathematics whenever we are using the proof of concurrency. So there are points here we want to be able to note. One is that prove that two triangles are congruent by listing all the matching and equal angles and sides. So using the four tests that we learned in the previous subtopic, it can be able to assist us in terming triangles as whether they are congruent or when they are not. So the first thing to do is for you to list all those particular equal or matching angles and sides. Then on each of them, you give reasons. Give reasons for each statement. You should be able to back up each statement with a reason. Then conclude. Then you conclude by writing concurrency statements. By writing concurrency statement and concurrency test. Which test were you able to use? Was it the side, side, side? Was it the side, angle, side? Was it the angle, angle, side? Or did you use the right angle, hypotenuse, and the side test? You should be able to give that allusion into that. Number two, other geometrical results. Other geometrical results can be proved by using properties of congruent triangles. So we understand that for those particular triangles to be congruent, we must have the side, 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 the side, angle, side, the angle, angle, side, or the right angle, then the hypotenuse, and of course one of the side being equal. So these are the two critical statements whenever we want to use the proofs. We now want to look at 3 examples on how we can be able to tackle a question in this. Example 1, prove that a triangle ABC is congruent to triangle ADC. So we have got 2 triangles. this is A, this is B, this is C, and this is D. Then this angle and this angle, this side and this side are similar. Now, we want to prove that actually triangle ABC, there are two triangles here. We have the top one ABC and ADC. We want to prove that actually both of them are similar. We'll begin from what we have been given. Whatever we've been given is that this side AB and side AD are equal to this angle and this angle we have been given, and that tells us that this is an indication that this is 90 degrees and therefore this is going to be 90 degrees. The other third critical thing that you can be able to observe is on line AC. Now whenever you look at AC, we have got triangle ABC, ABC, we have triangle A, this is a ACB, we have ADC. So if you look at this and this, it's one line that is being shared by the two triangles. What can it tell you? That AC is shared, therefore it is equal for both. And from there you can even conclude we have two sides which are equal and one angle. And by the virtue that this angle is not an included angle, then this is what? The side angle rule. Or if this side is equal to the other side of the other triangle, then automatically BC and DC will be equal. Then if they are going to be equal, then we can use the side angle side test. So here we are now going to come up with a series of truths or a series of statements. Number one is that in triangle ABC and triangle ADC, we have got an angle B which is equals to angle D, which is equals to 90 degrees. That is the first one. And you can be able to, of course, give a reason that given equal angles, you are told that this and this both are 90 degrees. So you have given a statement which is true and you have given a reason. Number two is about AC. It's common for both triangles and therefore it's going to be equal. So but that you can just give it as AC is common, and it is common for both the two triangles. So given equal sides, that is your reason. Now finally, if that is true, then that means, or we also have this AB and AD. AB is equals to AD. Again, the reason here is we have been given equal sides. The 2 marks indicates that the two sides are going to be equal. Given the two equal sides, AB and AD, they are equal. Now that we have those two cases, we have now two sides which are going to be equal, and we have an angle which is equal. And one of these is 90 degrees. Then that means that you are going to use the fourth test in concurrency about the right angle. the hypotenuse, because this is the hypotenuse and one of the side. Therefore, we can now be able to conclude and say that triangle ABC is congruent to triangle ABC. Under the test, right angle, hypotenuse, and one of the side. Example 2. Example 2, we are told that 1, prove that triangle ABC is congruent to triangle EDC. Part B of the question, hence proof that AB is parallel to DE. So the triangles are here. A, B, C, D, E. We are told that this side is equals to this side is equals to that side, then the rest is left free. Now here, how many triangles can you be able to see? We have got 2 triangles. We have triangle ABC, ABC. We have another triangle EDC. These are 2 triangles. We want to show that these 2 triangles are congruent. So the first statement, we are going to say that in triangle ABC and triangle EDC, there are things you can be able to note. AC and CE are equal. Also DC and CB are equal. AC is equals to CE. Reason is given equal sides. Again, BC is equals to CD, given equal sides. Now, there is this side and this side, there is this side and this side. What can you tell us about this particular angle? First, given that we are having them meeting at this particular point, then that will tell us that this angle and this angle are going to be equal by the virtue of them being vertically opposite. So angle ACB is equals to angle ACE. DCE. Reason? Vertically opposite angles are equal. Now we have this angle, we have this side, this side, this side, this side. Hence, we can be able to now conclude that therefore, the 2 triangles, triangle ABC is going to be congruent to triangle EDC by the virtue or the rule of the side angle side. Side angle side. The last one, or the last question, was for us to prove that AB is going to be parallel to DE. That is, AB and DE are supposed to be parallel. Now, by matching, we have been able to say that this angle and this angle are going to be equal. And if they are going to be equal, then by matching, this angle will be equal to this particular angle. And you can be able to see that BD is going to be a transversal, in that if this angle and this angle are equal, then this is going to be a transversal, and for it to be a transversal, that means it must have cut across parallel lines. Therefore, you can be able to conclude that AB is parallel to DE by the virtue of DB being the transversal of the two parallel points. So this brings us to the end of the discussion. The most important thing for you to recall is the concurrency test, the side test, the side angle side test, the angle side, and the right angle, hypotenuse, and the side test. Then know how you can be able to use them to be able to prove them mathematically. We have said for you to be able to prove, one, come up with those particular statements and give reason for each of that particular statement. Then finally go ahead and give your result. Are they congruent? Then if they are congruent, which rule did you use? So thank you for that.